All right. So because of that electron-electron repulsion term, we cannot separate the Hamiltonian into two parts depending on affecting different variables. Okay. But before we get into that, let's just talk about helium plus hydrogenic. Let's just review hydrogenic ion. We said that if you have a hydrogenic ion or a hydrogen atom, the ground state would have an electron that can either be either spin up or spin down. We already know electrons can either be spin up or spin down, right? So the ground state, for example, of He plus, you can write it as, to completely write the wave function, you not only have to specify the orbital, but you have to specify the spin. Is it spin up or spin down? So you can write it as spin alpha, spin up, 1s alpha. If you write it as 1s beta, you're saying that your electron is in the 1s orbital, spin down. Okay? So exactly what do we mean when psi is equal to 1s alpha? Well, let's look up the wave function for 1s. What would be a good place to look for it? The Orbitron website. 1s. The actual expression for the 1s function is this one right here. Here. So that's equal to 2z to the 3/2 e to the minus rho over 2 over square root of 4 pi. Okay. So in the case of helium, what's our z for helium? Helium plus. Z is 2, right? So that's going to be 2 times 2 to the 3/2 over square root of 4 pi e to the minus rho. Rho here is defined as 2zr over n. Okay? So e to the negative 2zr over n. Now n is 1 for 1s orbital, right? 1s, n is 1. So n is 1, what would this be? So this is 1, and z is 2. Okay. So what's our expression now? It's just going to be some constant. Let's just call that c e to the minus 4r, right? That would be your 1s orbital. So if you were to say something like this, what was that? E to the minus 4r. So this is going to be some constant c times e to the negative 4r. Okay, that would be the orbital, and then you say times alpha, whatever alpha is. That would be the eigenfunction for an electron that has a spin up. Okay, you can say that's alpha as a function of the spin coordinate omega. Okay, and then this one would be c times e to the minus 4r times beta, the beta function. Okay, the spin down function. Okay, so 1s alpha, when you specify the orbital, when you write a function that specifies the orbital and the spin, you have what is called the spin orbital function. Okay,